Rosalyn Silanan, and I am one of the group 8. So today we were going to discuss about the mathematics of graph. But in this video I am going to discuss and explain about the graph and Euler. So in this chapter, you will learn how to analyze and solve a variety of problems, such as how to find at least expensive route of travel on a vacation, how to determine the most efficient order in which to run errands, and how to schedule meetings at a conference so that no one has two required meetings at the same time. The methods we will use to study these problems can be traced back to an old recreational puzzle. So in the early 18th century, the Pejel River in a city called Königsberg, located in modern-day Russia and now called Kaliningrad, surround an island before splitting in two. 7 bridges crossed the river and connected 4 different land areas to the map drawn below. Many citizens of the time attempted to take a stroll that would lead them across each bridge and return them to the starting point without traversing the same bridge twice. None of them could do it, no matter what they chose to start. So in 1736, the Swiss mathematician Leonhard Euler proved that it is, in fact, impossible to walk such a path. Ibig sabihin nito, karamihan sa mga tao noong panahong iyon ang nagtangkang maglakad na magdadala sa kanila sa bawat tulay at ibalik sila kung saan sila nagsimula o nanggaling, nang hindi nababalikan at nadadaanan ang parehong tulay ng 2 beses. Walang sino man sa kanila ang nakagagawa nito, kahit saan nila piniling magsimula. So now, let's discuss what is graph. So familiar naman tayo sa graph, which is, pag naririnig natin ang salitang graph, is ang unang pumapasok sa isipan natin ay ang graph ay ito yung may line. So ano nga ba ang graph? Graph is a set of points called vertices and line segments or curves called edges that connect vertices. So let us illustrate and analyze the connection of this example. So this example, this diagram represents friends that are connected on Facebook. So each dot represents a person. And a line segment connecting 2 dots means that those 2 people are friends on Facebook. So, sa diagram na ito is about friends that are connected on Facebook. So, ang bawat dots or tuldok sa graph na ito ay kumakatawan sa isang tao. Or sa bawat dots ay may naka-indicate na pangalan, which means bawat isa sa kanila ay mayroong sariling Facebook. At ang line segment that connected 2 dots, halimbawa, sina James at Lisa. Yung line segment ni James is nakakonect sa kay Lisa. So, ibig sabihin, sila yung magkaibigan sa Facebook. So, may tinatawag tayong path. So, a path in a graph can be thought as a movement from one vertex to another by traversing edges. So we can refer to our movement by vertex letters. For example, di ba magsisimula tayo sa A, papunta sa B, then papunta naman sa A, then papunta sa C. So the one path in this graph would be A, B, A, C. So now, let's discuss about what is Euler circuit. So, Euler circuit is if a path ends at the same vertex at which it started, it is considered a closed path or circuit. For example, in this graph, the path A, B, F, G, E, B, and A is a circuit because it begins and ends at the same vertex. So, ibig sabihin, ang Euler circuit is kung ang isang path ay nagtatapos sa parehong vertex kung saan ito nagsimula, ito ay tinatawag na closed path or circuit. Halimbawa, sa graph na ito, magsisimula tayo sa A, papunta sa D, papunta naman sa F, papunta sa G, papunta sa E, papunta sa B, at papunta sa A. That's why it is a circuit kasi kung saan tayo nag-start, doon rin tayo nag-end. So, always remember that a circuit is kung saan ka nagsimula, dapat doon ka rin mag-end. So, another example is if a path A, another example is the path A, D, F, G, E, and H is not a circuit. Why? Because as the path ends at a different vertex that the one it started at. So, another example is yung sinabi ko kanina na A, D, F, G, E, and H. So, ibig sabihin, hindi siya bumalik sa letter A. That's why it is not a circuit. Because ang path na ito ay nag-end sa ibang letter which is H at hindi siya bumalik sa kung saan siya nanggaling which is sa A. So, unlike sa circuit, nagtapos kung saan nagsimula or bumalik siya kung saan siya nanggaling which is nagsimula sa A at nagtapos din sa A.
Assalamualaikum. Good day everyone. Before I start to discuss about my topic, first I would like to introduce myself. My name is Felicity S. Udasan. So, my topic is about the continuation of Ms. Rosalyn Sulaiman's report entitled Graph and Euler Circuits. So, I will give some examples for that topic. So, let me briefly discuss the Euler path and Euler circuit. The Euler circuit is a path that traces every edge exactly once. They start and end at the same vertex. An Euler path is a path that traces every edge exactly once. They start and end at different vertices. A path in a graph can be thought of as a movement from one vertex to another by traversing edges. We can refer to our movement by vertex letters. For this example graph, one path would be A, B, A, C. So, if a path ends at the same vertex at which it started, it is considered as a circuit. So, for this example graph, the path A, B, F, G, E, B, A is a circuit because it begins and ends at the same vertex. The path A, B, F, G, E, H is not a circuit, as the path ends at a different vertex than the one it started at. So, a circuit that uses every edge but never uses the same edge twice is called Euler circuit. The path may cross through vertices more than once. So in this example graph, the path B, D, F, G, H, E, C, B, A, D, G, E, B is an Euler circuit. It begins and ends at the same vertex and uses each edge exactly once. So, the path A, B, C, E, H, G, E, B, D, A is not an Euler circuit. Why? because this begins and ends at the same vertex but it does not use edges DF, DG, or FG. Here is the other example of Eulerian graph. So let us identify which of the following graphs has an Euler circuit in these given examples. In these examples, the Euler circuit is the letter B. Why? Because all vertices are of even degree. Because it is said in the Eulerian graph theory that a connected graph is Eulerian if and only if every vertex of the graph is of even degree. So as you can see here in the example B, it has even degree. Unlike the letter A that has odd degree in the vertices C and D. So here's another example of Euler circuit. Let us determine whether the graph shown here is Eulerian. So here's the solution. Each vertex is of even degrees, either 2, 4, or 6. So by the Eulerian graph theorem, the graph here is Eulerian. There are many possible Euler circuits in this graph. We do not have a formal method of locating one, but by trial and error, one Euler circuit is BAF, BEF, GED, GBD, CD. Now, let us proceed in the Euler path or Euler path. Here is the application of the Euler path. For example, a photographer would like to travel across all over the roads shown on the following. So the photographer will rent a car that need to be returned to the same city. It is possible for the photographer to design a trip that traverses all over the roads exactly once. So here's the solution of the given example. Looking at the map of roads as a graph, we see that a route that includes all of the roads but does not cover any road twice corresponds to an Euler path of the graph. Notice that only two vertices are of odd degree, the cities of Alameda and Dover. Thus, we know that an Euler path exists, and so it is possible for the photographer to plan a route that travels each road once. Because A and B, so that's abbreviating the cities, A and B are of odd degree. That photographer must start at one of these cities. So with a little experimentation, we find here that one Euler path is A, B, C, D, B, F, A, G, F, E, D. Remember that Euler path is path that travels through every edge of a graph once and only once and must start at one of the vertices of odd degree and end at the other.